Namaskar dosto, welcome to channel Toxicology on board. Today in this video we'll be discussing about another important DABT topic, that is alpha particles with respect to radioactivity. So the few questions with respect to radioactivity will get it in the exam. So we'll see what is the question. This question is taken from ABT recertification year 2000 question paper. So the question pattern is four option type of questions are there, which are not currently the same format. There is a little bit of change in the format. So, but still from this question and the concept, we'll try to understand about the radioactivity. With respect to radioactivity or radiation girls is also there as a topic in the DABT brochure 2026. Okay, so I have done one video on the radioactivity girls also regarding uranium and its radioactivity units. Also I have made one video, so I'll give the description in the I will give the link in the description. I would request you go back and read those particular questions also with respect to uranium, plutonium, all the radioactivity and the units also, and radium girls also, radium dial painters. So now we'll discuss this question only with respect to alpha particles. This question was previously asked in ABT recertification year 2000. Okay, the question is alpha particles are a type of ionizing radiation. So we need to understand when it comes to different radiations, no, which is ionizing radiation, what type of different forces will be there. So that radioactivity decay or van der Waals forces, all those forces, different types of radiations that you need to understand. So alpha particles are a type of ionizing radiations. So you have to read about what is beta particles also and gamma particles also. Next, these alpha particles, they will lose energy when passing through biological tissue. For example, this is my hand. Then this is alpha particle. If it bombards my tissue, from the tissue, this alpha particle can penetrate. It can go through this biological tissue. That is the reason it is more damaging. It is. Next are heavily charged particles. Yes, for this reason only it is helium 4 and 2, atomic number 2 as well as molecular weight 4. That's why it is heavily charged particle. Alpha particles have linear energy transfer. This LET concept is very, very important. What is LET definition also I have given in my one of my video. You will see in this video also, much greater than the gamma rays. So whenever you're reading about alpha particles, you have to read alpha particles, beta as well as gamma rays. The comparison you have to read. Okay, we'll quickly go through what are the important concepts. So right answer will be in the green text. That is all the four characteristic features. No, they are applicable to this alpha particles. Okay, so now we'll try to read what are the concepts that we can learn with respect to alpha particles. Alpha particles are highly ionizing, heavily charged particles consisting of two protons and two neutrons. This is very, very important. That's why it is four. Due to their high mass and energy, high mass and energy, these alpha particles, they possess high linear energy transfer, that is LET, lose energy rapidly over a short distances. Okay, and these alpha particles are easily stopped by paper or skin, acting as an internal hazard. Okay, then we'll see key characteristic of this alpha particles. Ionizing radiation type. As directly ionizing radiation, they consist of helium nuclei, that is plus 2 charge, emitted from heavily radioactive elements like radium and radon. So these heavily charged particles are there, radium and radon. They keep emitting these alpha particles. Heavily charged particle. Alpha particles are relatively heavy, that is 4 AMU atomic mass unit, and slow compared to other radiation types. Other radiation type means like gamma rays or beta rays, okay, which causes them to interact readily with the matter like biological tissue. Energy deposition, that is high LET. So always you have to do this comparison. So coming to this linear energy transfer, these alpha particles have high linear energy transfer, meaning they dissipate, means they will immediately lose the energy. They dissipate whatever the energy which is there in this helium nucleus. It dissipates. It dissipates their energy rapidly in short dense tracks. They deposit these alpha particles. They will deposit all their energy within a few cells. This particle, when it comes in contact with this, no, immediately within this vicinity of the cells, it will dissociate its energy, dissipate its energy within few cells, about 16 micron in the case of human tissue, causing significant cellular damage because of the high energy of this alpha particles and high linear energy transfer. Interaction with the tissue. Due to their high energy loss, that is high linear energy transfer, these alpha particles are not deeply penetrating because superficially the within the coming in contact with the cells, their only energy get dissipated. So penetrating deeper penetration into the other tissues will not take place. Okay, so due to their high energy loss, they are not deeply penetrating and cannot pass through the outer layers of the skin. Next, however, if inhaled or ingested, whenever these alpha particles are inhaled or ingested, no, they become highly dangerous, causing intense localized damage to the tissues, whether it is lung or respiratory system, like that. Okay. Well, as I told you, no, you have to always read alpha particles in comparison with other particles also, gamma rays and beta rays. So here we see a comparison between alpha particles and the gamma rays. Alpha particles have much linear, higher LET than gamma rays. Okay, which are low LET, weakly ionizing and highly penetrating. That means gamma rays are um, they're having low linear energy transfer, they're having weak ionizing potential, and they are highly penetrating into the deeper tissues. Okay, this is the comparison that you have to remember. I would request you to pause and read how this high linear energy transfer rays, as well as low energy linear transfer rays, that is radiation, are going to interconnect with the DNA, how they're going to damage the DNA molecule, which will become a part of this heredity, and it will lead to mutations. That also you try to read. Okay, then last slide we will be seeing, as I told you, we have to always compare alpha particles, particles and gamma particles. So we'll do a quick comparison, because in our exam, apart from alpha particles, any question with respect to beta, gamma, if neutron, if it comes, we'll be able to address in the exam. So what we can learn with respect to alpha particles is that alpha radiation consists of a fast moving helium, that is helium 4 and 2, atomic weight 2, atomic number 2, molecular weight 4, nucleus, and is stopped by a sheet of paper. If there is alpha particle, if it goes through a paper, this alpha particle gets stopped by this particular paper. Okay. Second one is beta radiation. Beta radiation consists of electrons, is halted by aluminum plate. So beta particle, when it comes in contact with the aluminum plate, it will get stopped by this aluminum plate, which beta particle. Coming to gamma radiation, consisting of energetic photons. Photons, when it comes to photons, no, you have to read about phototoxicity also, read about what are the specific ICH guideline with respect to phototoxicity. Okay, so photons, the radiation which is coming from your sun, it will be H mu. H nu it will be denoted photons. So gamma radiations consisting of energetic photons is eventually absorbed as it penetrates into the genes material. So whenever there is a gamma particle and it comes in contact with the whatever the exposed tissue or material is there, it goes deeper penetration. Okay, because gamma particles are having low linear energy transfer. Okay, they go deeper into penetration into the tissues or surrounding material. Okay, dense material penetrates a dense material. Here you can clearly see the picture. Coming to last one is, that is neutron. Neutron and radiation consists of free neutrons that are blocked by light elements like hydrogen, which slow and or capture them. So hydrogen, they will either capture or absorb these neutrons. Okay, so radiation interaction, gamma rays are represented by wavy lines. Here you can see charged particles, and neutrons by straight line. Smaller circles show where ionization takes place. Okay, so I would request you to pause here and read, go through in the description, in the link I will be in the description I will be giving the link with respect to. Uh, First of all, you have to read about Chernobyl incident, where the nuclear disaster took place. Read about radium dial painters, which is a part of the syllabus. Read about the Japan Fukushima nuclear plant emission accident. With respect to that, also you'll get one question, and also you'll get some questions with respect to like radioactive materials like uranium, plutonium, their units you will be getting, whether it is sieverts, whether it is gray, like that you have different units based on the radiation, what type of physical property that you are measuring. Okay, so these were the important areas. Previously, questions were asked in the same concept. Okay, thank you. Be curious. For any questions, you can always write a mail to arya.priyanka18@gmail.com. All the best for your exam.